2019 Paper 1 GCE on Earth Geometry. The diagram below shows points A, open bracket, 60 degrees north, 30 degrees west, B, 30 degrees south, 30 degrees west, and C, 30 degrees south, 75 degrees east. If the local time at point B is 15 hours, what is the local time at town C? So they want us to calculate the time which should be here. So part A. So now to calculate time at C, we need to know first the difference in time between the two longitudes. Town B, it is on longitude 30 degrees west. Town C, it is on longitude 75 degrees east. So we need to know the difference between the two longitudes. So say difference between BC equal to, so they are coming from different hemispheres, so we need to add, which is going to be 30 degrees plus 75 degrees. So the difference between B and C is going to be 105. 105 degrees. So now we have to convert this 105 into hours, which is in degrees. So now we'll say 1 hour is equivalent to 15 degrees. Then X will be equal to 105. We cross multiply. X times 15, it's 15x equal to 105 degrees. So now we have to divide both sides by 15. So now X will be equal to 15 into 105, which is equal to 7. So it's 7 hours. So the difference in time is 7 hours. So now we have time at town B, which is 15 hours. So we are going to get this 15 hours. And the time we have calculated in difference in longitude, we add or subtract. Now, how can you tell? If you are looking for the time which is going towards east, you add. So we are looking for the time which should be at town C, which means it is heading towards the east. So we need to add. If town C was located behind town B, we are supposed to subtract. So now since it is after town B and it is heading towards east, so we are going to add. So now we'll say 15 hours plus 07 hours, which is going to be 0 plus 0, it's 0, 0 plus 0, it's 0, 5 plus 7, it's 12, so we have to write 2, carry 1. Then 1 plus 0, it's 1 plus 1, 2. So is the time is the time at C. So it's 22 hours. We go to the next question. We go to part B. It takes a plane 6 hours to fly from A to B. What is its speed in knots? What is its speed in knots? So they want us to calculate speed. But we know that speed is related to distance over time. So we need to identify distance, we need to identify time. So time we have, which is 6 hours, but we don't have distance. So let's calculate distance first between town A and the town B. So this distance, it is coming from the Great Line, the longitude. So since it is coming from the Great Line, we have to apply this formula. AB equal to theta over 360 2 pi r. So now what is going to happen here is, where there is theta, we have to replace the difference in latitudes. So we have 30 degrees south and 60 degrees north. So we'll say AB equal to 30 plus 60, which is equal to 90 over 360 times 2 times pi, which is 22 over 7 times radius. So the radius we have here, it should be naught miles, which is 3,437. So now we are going to reduce. 2 into 2, it's 1. 2 into 360, it's 180. Then 90 into 90, it's 1. Then 90 into 180, it's 2. So AB equal to 2 into 2, it's 1. Then 2 into 22, it's 11. So now we have okay, so 7 into 7, it's 1. Then 7 into 3,437. So if we divide 7 into 3,437, we are having 491. 491. So we have just remained with the 11 times 491. So AB equal to, so 11 times 491, we are having 5,401. So if we round off this figure, it will be just 5,400 nautical miles. So this is the distance we have calculated. So now we can plug in into the speed formula, which is speed equal to distance 5,400 over time, which is 6. So 6 into 4 into 54. which is equal to 900 knots